Greetings. Welcome to our 36th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we're going to focus on our December 7th, 2021 live panel discussion webinar on allowable/action leakage rates. I'd like to quickly reintroduce our five distinguished panelists. First is Annette de Havilland, who is a member of the Division of Solid and Infectious Waste Management at the Ohio EPA. She's worked with the Ohio EPA for over 30 years in the solid waste program. Reese Younts is a statewide solid waste permit reviewer for the Tennessee Department of Environment and Conservation. Neil Nowak is a professional engineer and a project director for SCS Engineers based in their Denver office. Pat Elliott is the Director of Installation Services for Raven Engineered Films through their subsidiary Raven CLI Construction, Inc. And finally, Matt Chemnitz is the President of Leak Location Services, Inc. in San Antonio, Texas, and has conducted leak location surveys on over 4,000 projects. So panelists, thanks for joining again, and thanks for a great panel discussion. Based on all the questions, we received an additional 26 questions that we did not get to answer during the panel discussion. So I'm going to cover these 26. 23 were received during the panel discussion and 3 afterwards. So here we go on the questions from the live presentation that we did not answer during the panel discussion. Question number 1. In a reservoir that impounds potable water, is it possible to detect leakage and patch leaking locations with 100 feet of water over the liner? Any issues with the compound/paste to be used for patching with review agencies considering it a potable water source? Pat, could you handle that question?
Yeah, Tim, we've had some success doing underwater patching in potable water reservoirs in the past. Never down to those depths, and typically that needs to be applied by a diver. And the leaks are typically located using a dive method with a diver and a camera. And the main issue with the regulatory agencies with using the paste or the compound or the epoxy, depending on the type of product you're using, is to make sure it's NSF certified. And there are several products out on the market that do work. Most of our success has been in outside of the membrane area in concrete structures with patching cracks that allows the compound to get down into the crack to seal it. It is very difficult to stick to certain types of liners, so it really project specific, but that's my experience with that.
Thanks, Pat. And you mentioned NSF, just for the viewers and listeners, that's the National Sanitation Foundation, right?
Yeah, and NSF 61 is the certification for potable water.
Right. Okay, thanks, Pat. Next question is, what is the feeling in the industry right now on BGMs, which are bituminous geomembranes? I polled the panelists before this podcast, and no one's really familiar with BGMs in the United States. They're popular in international markets, but have not become very prevalent in the US. Next question, number 3. Are the methodologies presented in the 2017 World of Coal Ash Action Leakage Rate Calculation paper, i.e. EPA method using Darcy's Law, still appropriate for calculating ALR for landfills, or have new methodologies been developed since then? Neil, could you take that question?
Yes, thanks, Tim. Yeah, the EPA method that we use is still appropriate. EPA Part 254.302 of the Code of Federal Register. So yeah, that provides the calculation, the equation, and then you take various inputs regarding head, number of defects, size of defects, area. So it is still used for this application.
Great, thanks, Neil. And I have a question a little later about the number of defects for the listeners. But in short, with CQA, there's generally 5 to 6 holes per hectare. Without CQA, 25 or more, and that's with geomembrane installation. But I'll talk a little bit more about defects in just a minute. Next question. The QBAL concept, or quality-based action leakage rate, sets an action leakage rate based on an allowable hole size and orifice equation based on the installation quality expectations. Current hazardous waste regs specify the action leakage rate be calculated based on the capacity of the LDZ, or leak detection zone. MSW regs are not clear / differ, don't specify, since they are based on only a single line or single composite liner system. What does the panel think of specifying an initial action leakage rate based on the QBAL and then a secondary ALR based on the leak zone capacity? Neil, why don't you start with that?
Yeah, so you typically, when it depends on also where you're at, what state you're in, or what who the regulator is, and what you're needing to provide to under the permit condition. So as an example, in Wyoming, for an impoundment, there are different action leakage rates and different actions. So at like a 400 gallon per day per acre, you've got an action that you have to do something to fix the liner, the primary liner, within, I think it's a 1 year. Where if it goes up to say 800 gallons per day per acre on the primary liner, then your action is much quicker. So the state requires you to then go in within 60 days and find that leak and repair the leak. So the whole process here is getting the head off of the secondary liner, because your system is basically a couple of layers. Your primary liner is your first liner, you've got a leak layer, and then you've got a secondary liner that holds in the leak. So as long as you can, evacuate that secondary liner or the leak zone, then, you don't have any head on that and it can't leak through the bottom. So the system works when you then, proceed to evacuate the sump and the leak system. So I think that's what the question was asking.
Okay. Next question. Can the panelists comment on 1, any regulatory requirements for allowable leakage rate, and 2, precedent or practices for calculating the allowable leakage rate? Neil, I think this is similar to your prior answer about using the US EPA method.
Yes. So, again, applying that method and applying that equation, there's different inputs. There's holes per, defects per area. There's the size of the hole. There's the head on the. So in each instance, in each project, you need to really take a look at it, because if it's an impoundment and you don't have, say soil on top, then your instances in your equation of potential holes is a lot less than sometimes when you're installing a liner and putting soil on it, then that increases your risk or instances of perhaps holes or defects in the liner because of the impact of the installing the soil. And Tim, you did mention something earlier about CQA, and when you do have a CQA full-time in the field and making sure that the installation is going as it's supposed to, it definitely reduces the number of defects as found by Giroux in his paper in 2016.
Great, thanks, Neil. Next, number 6, how does determining an ALR for a heap leach pad differ from a surface impoundment or a landfill? Pat, if you could tackle that question.
Yeah, I think ultimately you need to look at the environmental impact of what you're containing. That's number one, and what's the ramifications of a leak. Number 2, you need to put in as many stopgaps to prevent leakage. So that include drainage, that can include a secondary GCL. But ultimately, you know, the environmental impact is what we're trying to avoid here. So you need to design the leach pad to reduce the leakage, just like in a surface impoundment and a landfill. So ultimately, it shouldn't matter if what you're trying to keep out of the ground is hazardous. So it shouldn't matter what it is, as long as it's hazardous. You should put all the design you can into avoiding any leakage.
Great. Number 7, in a true double-lined MSW facility with a leak collection system, how accurate is it to measure the amount of leachate collected in the leak detection sump? How do you do it, and over what period of time? How is the flow rate taken into consideration through a media into the sump and on a 2-to-1 side slope for the floor, or a 2-to-1 slope for the floor? Neil, sorry.
No worries. So yeah, and this is, you know, in a double line system, you know, you have, you know, your primary liner, your leak detection layer, and then your secondary that holds in any leaks from the primary. So, you know, as mentioned in the question, you know, the slope of the baseliner at the bottom of the landfill or the impoundment is sloped towards the sump. So, you know, 2-to-1 is, you know, that's pretty steep. You know, typically you have on the floor of these facilities probably, you know, 2 to 5% slope, and on the side slopes of the, you know, the berm or the, you know, surrounding excavation that, you know, down into the landfill is probably, you know, 4-to-1 or 3-to-1 sometimes, if you can maintain the stability of the liner on the side slopes that are steeper. So, you know, when you're measuring you know, the leak in a leak detection system, you know, the bottom of the landfill is sloped towards the sump, and the sump collects the leak, you know, the leaks through the primary. So the sump is sized, certainly, probably, you know, it could be various, depends on the size of the landfill, of the impoundment, but it could be, you know, say 20 feet by 20 feet, you know, 18 inches deep. And you fill that with a, you know, like a gravel medium, and then in that you put a sump riser pipe. So the riser pipe goes into the sump, and then you know, extends probably a few feet on the horizontal, and then comes up the slope in between the liners, and at this top of the liner, at the top of the slope, so that that's where the pipe is accessed. So you can put in, you know, water or you know, indicator, you know, levels that you can put in the sump itself, and then if there's a leak and it collects in the sump, then the water, you know, level indicator is triggered, and then it automatically can, you know, notify the operator that there's leak in the sump. So then you go in, all right, there's a leak. So all these action leakage rates are based on, you know, per day. So you go in and you evacuate the sump of water, whatever water is in that sump. You mark your time on your watch, say, you know, 10 a.m. You've got as dry a possible sump as you can get, and then you monitor that. The next day, you come back at 10 a.m., 24 hours, right? That's a day. Then you measure how much water has been accumulated in the sump over that 24-hour period by pumping it back out. You measure the amount of volume, and then that's your volume of leak that's been collected within that area that the sump is collecting from. And you base that on, you know, you divide that into an acre, so it's an action leakage rate. Then you have a leakage rate, right? You have a gallons, right, per day, 24 hours per acre, and you measure that, and you know, if it's, you know, 2.5 acres, well, you know, divide by 2.5, so you get that volume. So now you've got a volume of the gallons that is leaked per day per acre. And then now you have at least a volume that's been calculated, right, and measured. So then you use that against your action leakage rate.
Right. Okay. Thanks, Neil. Looks like one more question about leak detection and leakage rate. Are liners with built-in leak detection grids appropriate for some situations?
Yeah, I mean, I would say that, you know, those are more expensive, and Pat might be able to give me a better answer here, but they're just those type of geomembranes are used more for smaller installations, maybe under a tank or you know, a vault or something like that, where, you know, in a landfill or in a large impoundment, you know, you're talking about, you know, 10, 20, 30, 40 acres. I mean, that's a lot of liner, right? And that's can get fairly expensive. So I don't know, Pat, if you wanted to add something there.
No, you're correct. I mean, we've seen the cables installed. It's kind of common in tank applications, above ground tanks, like steel tanks that, you know, you're putting a liner in after the fact, or you're putting in a secondary containment below a tank. A lot of times we'll put in you know, metal grids or something like that. But in large impoundments, I have not seen one in my 30 years in the U.S. So I hope that answers the question.
Great. Thanks, Pat. Matt, we've got a couple of leak location questions here. Number 9, can a leak detection survey, that must be a leak location survey, be conducted when the cover layer is a metal ferrous slag?
So this question is a good one. We have not tested that type of cover material at the moment. We've tested many layers that do have high conductivity, such as a brine solution or even some with metal in them, and they do test okay, and you can still find leaks. The reason is, and this is important, is that your cover material has to be consistent. If you had a soil covered layer with a piece of metal buried in one spot, that one piece of metal would conduct all the current. But if it was spread out evenly along the entire cover layer, it would allow us to find leaks that way.
Okay. Next, how do you get conductivity below the primary liner resting on a geonet?
So for this question, what we're assuming is that this is a double line system, so they have a geonet between. Therefore, there's nothing conductive between the layers to find a leak through that primary liner. And what you do in this case is you have to have something conductive between the two. So there's multiple options. There's different materials. Simply, you could put water between the two. That's the best. And it's just a thin layer of water that's consistent. That way, a leak shows up. It goes through the top and is brought back through that thin layer of water back to your sump. If water is not an option, again, there's multiple different materials you can get. You can get clay, GCL. There's stuff out there that you can use to get that leak current back, but it definitely has to be something conductive between the two. If this was just a single layer, that would be different, but because it's double, that's why this is important.
Right, and that all has to be installed up front, right? Because you're going to place the primary on top of it.
Right. So you couldn't go back and put something conductive between there. The only thing you can go back to after the fact is putting water in between the liners.
Right. Okay. Next one, Matt. Oh no, I think this is for Pat. Can cables below the geomembrane to allow locating leaks under any load? Are they used in the U.S. as well?
Yeah, that's back to the cables that I was discussing under tanks, and like I said, I've never seen them in any like surface impoundment or landfill construction. It's pretty isolated to very small installations, and the only ones I've seen with all my years of experience is in above ground steel tanks where we're putting a membrane in that, and we'd like to detect leakage below it.
Okay. Number 12, should the regulators regulate the liner installer not to be one conducting the leak location survey? We had this issue last year. In other words, maybe a conflict of interest. So Matt and Neil, why don't you two take this?
Yeah, Neil here. So yeah, so typically the survey is performed by the CQA engineering company, or the third party CQA engineer. So they hire the leak detection survey company, like Matt's company, to come in and perform that, and then they provide that information to the third party CQA, who is working directly for the customer, the client, the landfill owner, the impoundment owner, whoever's installing the liner. So and the third party engineering is typically a certification. So the third party CQA is putting their professional seal, PE seal, on the report, and so therefore it's done very above board.
Matt?
I would agree with that. I would not have the same person installing do the leak location survey. It is a conflict of interest. You just don't want any possibility of any questions about what was done. Having a separate company out there, it's a different set of eyes. It's just a more thorough way of testing and making sure everything is covered.
Great. Okay, number 13, all plastic membranes have a permeability factor. Therefore, there will always be a leak. Now, the allowed leak should be measured after accepting this permeability or transmissivity of or actually vapor transmission of the geomembrane, which is different for every plastic, height of load, and thickness. Pat, can you respond to that question?
Yeah, I mean, I think we're talking about hydraulic conductivity or vapor transmission, and yes, it is true, but it is such a minimal, a minuscule amount of leakage that a membrane, you won't even get the subgrade will be maybe a little moist below when you're tearing out a liner, but you're not getting enough through there that it's going to be detectable. I mean, you're talking about, like, for example, in an LLDPE, 1.47 times 10 to the minus 10 centimeters a second. So we're talking about such a minuscule amount. And really the proof of that is, we have, we've had to pass several leak tests, and we have several of these double line containments scattered across the U.S. and in very different markets, from agricultural to oil and gas to, several different markets. And when those sumps are, those sumps do not fill up. There's not enough recordable leakage. So it's very minimal, and it's almost undetectable. And so that would be my answer to that.
Okay, thanks, Pat. Next is Giroux's and Bernoulli's equation are established standards for estimating leakage in landfills and other low head environments less than 3 meters. What methods are appropriate for impoundments that have a head that exceeds 3 meters? Neil?
Yeah, good question. So yeah, we use the similar equations, and we adjust it for the head. There's some I guess adjustment of the equation there that but I don't have all the specifics on that, but we do use those adjustments to the equation. It's usable, it's doable. Perhaps isn't 100% exact, but we're modeling. So when you model things, it's only as good as the input, right? So we're estimating. So it can be done, and we've done it before here, and then some states that we've done it with have approved those calculations.
Okay. What, Neil, I think this one also is for you. What is your recommendation regarding leak location testing of a secondary geomembrane, given the importance of its function, basically containing leaks in the primary liner system.
Yes, it's definitely if you can get it done on both liners, the primary and the secondary, that's for sure going to give you a better quality control. And again, when you're installing, and when you've got equipment and things running around, and hoses and things dragging, and sometimes impacts the liner, or the liner seams and things like that. So then you come in and you do the leak detection on that secondary liner, and I think Matt can talk about doing a leak detection on a secondary liner that doesn't perhaps have a below the leak layer. So that's you can do that testing on that kind of liner. It just takes a little more for the leak detection company there to work with, but I'll let Matt handle that question on what it needs to be done for the secondary liner. But it is recommended, and to do that, that would be it increases it makes your quality assurance better for your certification of the installation.
Matt?
I would just add to that that you cannot test the secondary layer once it's been covered up by the primary. So if there's any concern of should you or should you not test it, definitely make sure you're comfortable with your decision before you cover it up with the primary, because the only way to test it after that fact is to take the primary back off, and nobody's going to do that.
Yeah. Okay. 16, what design changes, including penetrations, can you suggest that will help minimize leakage and facilitate leak location testing in ponds? Matt, why don't you start with that one?
So I would say the things that you can use to minimize the leaks and to do a good leak location test is anything that's conductive in there. So when we're looking at ponds, we have metal catwalks that sometimes go into those. Those are okay, but just make sure they're resting on maybe a rub sheet, and when they go out to earth ground, make sure that they're isolated from metal to dirt contact by some kind of plastic covering or something around those feet there. That really tends to help. The pipes, the penetrations, if you can't get away from those, do wrap those in a thick trash bag or something and tape those up and cover up any kind of metal banding around those. That helps a lot. And if you have metal cables, which you see a lot that go out into the pond to kind of hold an aerator in place, those metal cables, if where they hook into typically concrete outside of the pond, if you can just put that eye hook, you can wrap some rubber around it. That'll really slow down the leakage of electricity and not the actual leakage. So it'll all these little things will improve. But the best thing is to take a picture of what it is that you're testing, and then call somebody and ask, what can I do before anybody gets here to test it, so we can make sure that we minimize any kind of interference.
Okay. 17, Annette mentioned that there is now 30 years of testing and the standard is ancient. I often calculate allowable leakage rates, alert levels, etc., based on equations 20, 25, and even 30 years old that are based on the nascent information. Will the standards be updated to reflect the state of the practice and or better practices? So, Annette, I'm going to let you weigh in on that.
Oh, yes, absolutely. As a regulator, let me stress that we do make a distinction between guidance, standards that are in guidance, and standards that are in rule. Guidance is not enforceable. So if there's a whole bunch of different ways of doing something, as long as you justify that the one that you chose fits your situation, that should be acceptable. But if it's a standard that's in rule, then you're just going to have to wait until those rules get updated, which we're constantly doing, to get the best of the science out there in the regulations.
Great. Okay, 18. When I have reviewed the CQA seam welding reports, many times I find that the times reported for their seam welding times, welding machine speed, weld lengths, etc., it appears the information was just filled in and not realistic. Oh boy. Neil, why don't you tackle that question?
Yeah, so this, this brings us back to the third-party CQA, and having a full-time, one or two people out there, depending on the size of the project, and each day when the welding crew, comes on site, there's trial welds off to the side, and you need to maintain good quality assurance to make sure that the welding machines are calibrated correctly, and of course hiring a liner installer that has qualified and certified welders really matters. So make sure that your liner installer is it IGA certified, Pat? What's the
right? IAGI.
Yeah.
International Association of Geosynthetic Installers.
There you go. So with someone, with an installer that has that certification, and so they're going to do the right thing and fill out the paperwork and do the trial welds in the morning. So say the morning's cooler, your machines are going to be calibrated a certain way, and with the liner thickness and what kind of liner you have. And then in the afternoon, perhaps when the sun comes up and it becomes a hotter day, well, then you have to do another set of trial welds, right? So you do another set of, because then the welding machine, has been sitting there for maybe a half an hour from lunch, needs to get warmed up again, and then needs to adjust the temperature based on what the day is, and also, just to make sure that you're welding at the right temperatures and speed, and then you do all that trial weld stuff right out in the field, destructive, pull that apart, do the peel and shear, and then you record all that, and it should be done in front of and under the watchful eye of a third-party CQA engineering firm.
Okay, thanks, Neil. Annette, the next one's a long question for you. A coworker of mine could not attend but wanted me to chime in. I was planning on putting in my 2 cents. Let me get that. ALRs for impoundments being dependent on the storage capacity and pump out capacity of the sump, so that the leachate does not back up onto the lower liner per California regulations. Leachate in the landfill is different than leachate in an impoundment, in that landfills have the LCRS above the upper liner and are supposed to have leachate accumulating in the LCRS, whereas in an impoundment, the LCRS is below the upper liner, and leachate in an impoundment indicates the upper geomembrane or liner is leaking. The ALR for a landfill is dependent on the rate that leachate is generated by rainfall infiltration and waste decomposition, while leachate generation in an impoundment is dependent on the size of the hole in the upper geomembrane. Title 27 does not dive into these differences too much. Do you have any comments?
Okay. Well, there's been quite a few questions on the differences between, landfills and impoundments and leach pads and whatnot. I'm going to kind of strip it down to the basics and say you need to, at least from my perspective, let me get back to that as a regulator. I want an action leakage rate that's going to distinguish between what is moisture that's in the environment. It could be groundwater seeping in. It could be construction water that's being squeezed out. It could be condensate that's being created, distinguishing between that liquid collected in the leak detection system and liquid that is coming through a hole or a flaw in the liner system. So if I have I'll call it a wet liner design or a wet situation, I might have to have an action leakage rate that's a little bit higher. Or if I have an impoundment that's got umpteen feet of liquid in it with that head pushing down on that hole, to my mind, that compared to a landfill, that's like a gusher So I might be able to live with a higher action leakage rate in those situations versus something like with a landfill where you're limited to 1 foot of head. You have a hole under that and it's just kind of be seeping out. So I'll need a lower number, because it's not a gusher. Or if I have a drier liner situation where I don't have the groundwater, I don't have construction water in native soils to worry about, I might be able to bump that action leakage rate pretty low. So I'm going to say you kind of need to look at all the factors involved in your environment to figure out what an appropriate action leakage rate would be for determining if there really is a hole in your liner.
Right. Okay, number 20. As long as leak detection system isn't entirely saturated, doesn't matter what the ALR is. Unsaturated leak detection system tells me that the double lining system is working just fine. Neil?
Great point. I agree completely. So yeah, if the secondary, if the leak layer or the detection system is dry, then the primary liner is working, 100% as a, impounding layer. So there's no chance that whatever's in that impoundment or landfill is going to make it out the bottom of the system, right? So good point. Perfect.
Yep, I agree. 21. On a surface impoundment, as long as the leakage between the primary and secondary liner remains in an unconfined condition, the head on the secondary liner is not more than a fraction of an inch for a geocomposite drainage layer. Even if there was a leak in the secondary liner, the head forcing liquid through the defect is minimal. Neil, that's sort of similar to the last question, so why don't you take that?
Another good point, and I agree completely. And if that's why there's action leakage rates. So sometimes you do have a little bit of water in the leak system, and as long as it doesn't go beyond that allowable leakage rate or action leakage rate, you're still collecting water in the sump. But if it's not, say 1,000 gallons per day per acre, say, right, just a number. But if it's 850 gallons per day per acre, well, you're below the action that you need to do anything to the primary, and it's seen that and then but the thing is, you just need to keep that secondary layer, right, or the leak detection layer in the sump. You need to even if it says 850 gallons per day, you still should evacuate that leak detection system and keep that as dry as you can. So even if you have a few gallons of water in there, if you can pump that out and keep that leak detection layer dry, then again, there's no head on the liner for the secondary liner, so it can't get to the ground. It can't get out the bottom and impact the ground.
Right. Okay, 22. The secondary liner in a surface impoundment is the containment barrier layer. The primary liner just serves to counteract the head acting on it and prevent head on your waste containment barrier. EPA 1 foot of head limitation. Actually, that sounds similar, but Pat, why don't you take a stab at this question?
Yeah. So, I mean, from the standpoint of the installer, we all too often we run into situations where we'll go install a secondary, or a leak detection system, double line containment, or whatever the application is. And once we leave site, they got what they paid for. They pump water in there and they forget it. So ultimately, the education piece is what I am looking at here. We need to educate owners, engineer and operators of these systems to treat them like there's daily monitoring. There's, it's really key that they understand that they need to operate these systems, it's not just an impoundment out in a field. They pump the water to there and they forget about it, because all too often we run into several problems where they do develop a leak in their primary, and they allow that water just to build up to the point where now you get gases trapped, you get ballooning, you get whaling of the primary liner, and you have significant head on your secondary liner. So from a different perspective, it's really key that we educate the operators and the owners, and produce good O&M manuals at the end of the project once we turn it over for operations. So I think that would be my only added thing, added point to this that Neil didn't cover.
Great, thanks, Pat. Number 23, last one of the questions we received during the panel discussion. Can you, Matt, can you handle this? Can you talk about what size hole you can find with leak location surveys on 1, bare liner, 2, geomembrane with a geocomposite, 3, geomembrane with leak collection and removal gravel, and 4, geomembrane with gravel, LCRS, and operations layer?
Okay, so for all of these, very small leaks can be found. When I say small, we're talking about 1 millimeter in size. Will we always find 1 millimeter size or larger on all these situations? No. It depends on certain preparations and how the site is constructed. So for number 1, just briefly, that one's simple. It's a bare geomembrane. As long as moisture can get through that hole, it can be detected. For the second one, geomembrane with geocomposite, you want that geocomposite to have moisture to it. So if it's going to be under your primary, it's a good idea to try and wet that geocomposite before you cover it. That way that moisture is held in there, and when you come back to test it, it'll be able to conduct right through that composite. When you have gravel on top, same thing. The gravel does conduct the current, but it's a good idea to wet that sometimes as you're testing it just to get the best results. And the geomembrane with the gravel, LCRS, and operations layer, that one you really have to make sure you have moisture all the way through. I'm talking from top to bottom all the way through. You don't want a wet surface and then it's dry on the geomembrane, because then that current will not be able to conduct through the liner. So moisture is the key here, and isolation around the perimeter, and you can find leaks as small as 1 millimeter on all these.
Great, Matt, thanks. Okay, we have 3 questions submitted after the live presentation. So here's the first one. I feel it would be valuable to understand how people are designing/calculating the action leakage rate. The US EPA defines the criteria of the leak detection system capacity with 1 foot ahead on the liner. However, we find this may result in high ALRs. Also, we must be careful that the ALR is not too low and creating undue issues. In our practice, we have relied on estimating leakage through a reasonable number of geomembrane defects. Also, what are landfill measured leakage rates? So as I mentioned earlier, J.P. Giroux in 2016 has published a paper titled Leakage Control Using Geomembrane Liners. In that paper, he provides some recommendations for a reasonable number of geomembrane defects. So with just after geomembrane is installed with CQA techniques, you can expect 1 to 5 holes per hectare. After geomembrane installation with no CQA, 25 or more holes or defects per hectare. After cover soil is placed, then an additional 1 to 20 hectare holes per hectare can be encountered depending on the care taken in spreading the cover soil. So if anybody else wants to dive in on measured leakage rates, if not, let me go to the second one. Neil mentioned that a bare geonet would be used for leak location system. Would not impingement of the geonet strands into either the primary or secondary geomembrane be a concern, as it would affect the integrity of the geomembrane? If the primary has a GCL underneath of it, then that would not be an issue for the primary liner, but still for the secondary liner. So Neil?
Yes, all right, good question. So yeah, so I was mentioning more of a rigid liner and a situation where the geogrid and the liners would be, compatible or similar, or more, so there wouldn't be that much impingement or anything. So if you're using a softer liner or something different, that perhaps the leak detection layer wouldn't be just a bare GeoNet, it would be a geocomposite, which is a GeoNet that has, the geo fabric on both sides. So it's like a sandwich. So that helps to protect the liners from impingement from the, the load that's being applied. And then, so you won't have that, the liner either being moved into the void spaces of the GeoNet or any impacts to the geomembrane from the GeoNet. So when you have two geomembranes on both sides that are rigid or similar in what the product is, then a bare GeoNet can and is likely used most often.
Right. Okay. Last question. For a subtitle D liner system, would a GCL placed beneath the geomembrane provide better leak protection for small leaks in the geomembrane than the prescribed 1 × 10⁻⁷ centimeters per second compacted soil liner? Would it be better to use GCL instead of compacted soil liners in landfills? And maybe Annette and Neil, if you both could weigh in on a GCL as part of the subtitle D single composite liner system.
Yeah, so as far as, when you use, a GCL under a geomembrane, and, there's been papers and studies on this as well. So I don't have those references, but we can certainly provide those if that person's asking this question. If there's a small hole and the GCL is, in intimate contact with the liner, and that it leaks a bit through the hole, well, that's just going to swell that GCL at that point, and it tends to heal the liner at the hole, so it fills the hole and really does a good job of, clogging that hole, so it, reduces any leakage. So as a quantitative number, I don't have that number, but it certainly has been studied, and there are certain studies that do explain how that works. I don't know if Pat, you have something there, or Annette.
Yeah, I'll say that in Ohio, we were concerned about the ion exchange converting the sodium bentonite into calcium bentonite, which has a higher permeability. It's not as an effective liner when that happens. But after we studied the situation, at least for municipal solid waste landfills, we agree. It is basically a superior material to using native soils. Now, for some of our industrial landfills, that may not be the case because the chloride or the ion levels are so high. But generally speaking, yeah, GCLs are pretty good. That's our opinion.
Okay.
Yeah, the only thing I would add to that would be it is crucial that you get good intimate contact, and that's really important with any system, even if you're, above soil, putting the liners directly on soils below, because intimate contact really affects that. Wrinkles can cause a lot of problems if that leak is on the top of a wrinkle. So.
Okay, great. So that's the end of our questions. 26 additional questions. Thank you, panelists, for taking on 26 additional questions. So I'd like to close by thanking Annette, Reese, Neil, Pat, and Matt for joining us again, and thank all of the listeners for their questions and listening to this podcast. If you have any additional questions or like additional information, please send questions to the FGI at fabricatedgeomembrane@gmail.com, and we will pass the questions on to the appropriate panelists, and they will respond to your question. So everybody, thanks for attending, and the panelists, thanks again for a great panel discussion in this podcast. Okay, see ya.